Welcome to the Genesis Flight College online video presentation, Flying Without a Track Bar. The Garmin G1000 is a superb flight management system in that it does many things for you and reduces your workload significantly. The addition of an autopilot reduces your workload even further, but it does so at the cost of pilot proficiency in basic IFR flying skills. It is entirely possible for you to complete IFR training at the Group 1 level without ever having to use or even be acquainted with basic procedures. This presentation will show you a few basic IFR procedures that will give you alternatives to use in the absence of a track bar. So here's our PFD, and your main indicators for IFR flight are the inverted chevron for pitch and the bank indicator for roll. Now, this indicator here may or may not sit right on the horizon line. The white line is the horizon, not this seam between the light blue and the dark blue. The horizon is that white line. And it would be actually highly unusual for the symbol to sit on that line. It would probably only sit there in a high-speed situation when your angle of attack is quite low. So in this situation, you find level flight and observe the position of this chevron, and then for that particular speed and configuration, that is your level flight. And so when you're moving around the PFD, looking at other items, you always come back to this, and you're always looking to see that it is, yes, it's still in the same position. Because if it isn't, then you would have changed from your level flight attitude. So it takes a little while to find level flight if you were just using this symbol. But you've got the bird here with synthetic vision on most of our airplanes. And that is the indicator that shows where your aircraft is going. If you maintain this attitude and heading and so on, that is where your airplane is going at the moment. And so in this case, it shows that we're heading 275 down here, but we're actually moving this way because there is this 12 knot wind pushing us to the left. And it also shows that you're not quite level, because if you were level, then this horizontal green line here would be right on the horizon. You're slightly above. And that checks out because we wanted to hold 5,000 feet, and we were at one time, but it is just slowly climbing up. And it's not a fast enough rate of climb to trigger some sort of number here, but you are indeed going up. So with pitch control, you're always looking at this position to make sure that that chevron is where you want it to be. Your secondary indications are altitude, and if that is changing, then you know you're climbing or descending, so you have to come back here and either reset the position of this or get back to your known level flight position. Same thing with a VSI indication that would tell you that if you want level, you better change this. And even airspeed. If the airspeed is changing and you haven't touched the throttles, the only way that can happen is for you to either be starting a climb or starting a descent. Similarly, with the bank angle, you're looking at this primarily to maintain wings level. If your wings level and the brick is centered, then your heading should stay the same. So in this situation here, the brick is actually a little bit out to the left. So you're pushing a little too much on the right pedal, and the heading or the bank is about 1 degree to the right. So you should be in a right turn. And this little indicator here is the direction of turn indicator, and it's showing a very slight right turn. So you are flying 275 and you're maintaining this actual track. Now, if you were flying, say, an ILS approach or an LPV approach, and you were using the track bar, you would probably never even look at this heading. All you're interested in is making sure the track bar is lined up. And when it is, you're happy. And when it's not, you're making a correction. But you seldom, if ever, actually look at the heading. But when you're flying without a track bar, the heading is all important. So when you get onto a particular track, you have to determine what is the heading that's going to hold you, given the wind conditions. What is the heading that's going to hold you? And once you know that number, then with your cross-check, as you're looking around at all the various indicators, if you see a change from that heading, then you can turn back to it. You don't have to go up here to see that you are, oh, am I in a right turn? Am I in a left turn? No. You know, if you've gone off heading, you know you have turned. So that's when you use these indicators to set the proper turn, or set the proper bank angle in order to turn back to the heading that is going to keep you on track. So this becomes a very important secondary indication for the roll control. And one last thing is, when ATC asks you where you are, what is your position, they are expecting an answer in relation to either a VOR or a GPS waypoint, or even possibly an NDB. And so your answer in this case, where are you, is you are always on the tail of the needle. So you are on the 312 radial of the Wyerton VOR at 15 DME. And that would be the correct way to respond to a position statement. To go back to roll, as far as roll goes, when you are flying IFR and you're given a turn, you're expected to turn at a rate 1. So indicator right out to the rate 1 marker, and that equates to about 22 degrees of bank at the speeds that the DA40 and 42 flies at. With respect to climbs and descent, with climbs, your indicated airspeed does not remain the same in a really big climb. So once you get into professional mode, when you're flying jets and you're up in the 30 to 40,000 foot regime, you will see that the indicated airspeed decreases as you climb up. DA40, DA42, that doesn't happen at all. But with the 40 and 42, climbing at a constant rate of climb does make a difference. And once you get up to 8,000, 9,000 foot levels, you can easily get yourself into a potential stall situation. And in fact, you'll probably even hear the chirp of the stall warning tone if you were climbing with VS, just maintaining a constant rate of climb. So that's why we prefer to fly climbs with FLC, which will maintain a constant indicator. And as I say, if you're really going up to extreme altitudes, I'd say anything over 15,000 feet, then you would be reducing your indicated airspeed in the climb to maintain the most efficient climb. Another thing about trimming is that if you are in cruise flight level and you initiate a descent, all you have to do, and presuming that you have perfect trim as well in that level flight cruise attitude, assuming that, to start your descent, you just roll the throttle back. And trim will set an airplane up to hold a particular airspeed. Now, particularly with the A40, it's got such a lift equation that it is really susceptible to wind gusts and so on, so it doesn't do it really precisely. but the DA-42 is better because it's heavier. And basically, once you've trimmed the airplane, the airspeed will hold plus or minus a few knots, 2 or 3 knots, with a power reduction or even a power increase. Then you'd be climbing at still the same indicated airspeed. So the key thing is to know power settings for given rates of descent, and then things become extremely easy on your standard arrival pattern. When you start to go down, you bring it back, say, to, in the case of the 42, 40% power, and you get a 650 foot per minute rate of descent, and you're happy. It just stabilizes you like that every time. And the other thing is, glide path intercept, for instance, if you set the throttle at 48% with the gear and flaps down, and you're on a 3-degree glide path, whatever your airspeed was when you started, you know it's going to roll back to about 100 knots on the 42, and then you can just continue down the glide slope without much concern. And one last thing on using the various indicators. The bird is a superb ally when you're flying a 3-degree glide path, because this is a 2.5 degree mark here, so if you set the bird just right about here, you will be at a 3-degree glide path. Okay, in this situation here, we're assumed to be at 5,000 feet, and we're flying inbound to the Midland VOR. I'm using autopilot here just to keep the trainer level and to not to hold headings, so all it's doing is keeping us level at 5,000 feet. But the instruction here, the main points are discussing navigation with only the bearing pointer. So we're tracking inbound, and we should be on the 090 radial for this particular airway. And we're not. We're inbound 084, so we're 6 degrees off. Now, how much distance is that? 6 degrees. So we'll go to the 1 in 60 rule, and 6 degrees of error at 60 miles is 6 miles of distance error. We're at just under 35 miles, so we're a little over halfway. So our distance error just is a little over 3 miles. And that's a pretty significant amount. The airway is wider than that, but ATC will bark at you if you're anything more than 2 degrees off center line. So they would have been talking to you by now if they'd seen you this far off track. So we want to get back on track. How do we do that? Well, what's going to happen to this bearing pointer if we continue straight ahead 106 degrees? And what's going to happen is it's going to continue to move this way. It'll go through the wingtip, and then it'll be pointing behind. So that's obviously no good. We want to turn to the over here to get the bearing pointer to the right of our heading, so then it will move further right and eventually latch on to the 090 bearing. So that's one way of thinking of it. Another is that your position, you're always on the tail of the needle, and if you're inbound 090 to a particular point, then you want to be on the 270 radial, i.e. here. So you're there, you want to be here, you've got to go left. So whichever way you're thinking about it, we want to turn left. Okay, so I arbitrarily picked the heading to turn to a 053, and you can see now that this is going to move to the right. So the next question is, when do you turn to roll out 090? If you wait till the bearing pointer is right bang on, depending on how much angle of turn you've got and what the wind's doing, you may not be on track when you roll out. So you have to think about things that are going to affect your turn, and one is the wind and the other is the number of degrees that you have to turn. So in this situation, What's the wind doing to us, by the way? It's pushing us, it's helping us. It's pushing us to the left, which is helping us move this bearing pointer closer to 090. All right, so we're getting really, really close. You can see it's almost on 090. And so given the wind and the amount of turn we have, it's about time to turn. And I arbitrarily picked 097 because the wind is coming from the right. It's just got a small bit to turn, and that should work out. But what are we at here? 25.9 miles. Just almost 7 miles later, the bearing pointer has started to move off to the left. So I leaned a little too much into wind. That 090 was a bit too much of a heading off of the actual inbound bearing. So I'm going to make a correction. But I didn't turn over here to put the pointer on the right because it's so close that I'm just going to let the wind push me to the left. So I'm going to hold 090 degrees, and I'm going to let this wind push me to the left. And then when I get the bearing pointer on the 090, then I'll set a new heading, and that new heading will be 095. And then just to see how close it really was to the track, I engaged the autopilot, made it capture the track, and with 090 set in, there's 090, and we're really, really close. Okay, so that was the general statement on where does the bearing pointer move as you change heading. Now we can formalize that into intercepting an inbound course. So here we are on the 270 at 14 DME. And let's say ATC directs us to fly inbound 060. So it wants us to fly there. So which way are we going to turn to make that happen? And the rule is desired, which the desired is 060. So desired to the needle, the tip of the needle, plus 30. So the needle was on 090, plus 30 is 120. So turn to 120. And what's going to happen? This is going to move gradually over to 060. And then again, we've got, 60 degrees to turn, and we've got a fair amount of wind pushing us to the left. So we're going to start maybe 3 degrees before the bearing pointer actually gets to the 060. And then you pick a heading to roll out on. You're not going to roll out on 060 with that wind. And so I picked 065. And here's the cheater. The track indicator is showing we're actually tracking maybe 059 or 058. And so maybe my 065 heading is not good enough. We're at 7 miles now from this next, still doing 06, or correction, I made a correction, that's what I did. And so now we're back to bearing pointer on the appropriate bearing. So the next event is intercepting an outbound course, and we are on about the 025, and we're asked by ATC to fly outbound on the 340 right there. So this one is easier to see. You can see that you got to turn left. You're here, you got to go over there, so you got to turn left. And the rule is tail to desired 340 plus 45. So that swings you right around to 295 degrees. So we turn to 295, and you can see that the bearing pointer is going to continue to swing this way, and the tail is going to swing that way towards the 340. And we're getting close. We've got 45 degrees to turn, and we've got 12 knots of wind. And once we roll out, the wind is going to be pretty much on the nose. So we could probably wait till it might be about 2 degrees in here, and turn to a heading of 340 and see how that looks on the rollout. So there we are, we're rolled out on course. And got a slight bit of wind here from the left, so eventually it would probably blow us out to the left. So you might pick a heading of 339, something like that eventually. But that's all you need for intercepting a course outbound. Now here's the interesting one, point-to-point navigation. And with the waypoints being the primary means of navigation, GPS and waypoints, it's probably not going to happen very often. But if you were, for instance, being vectored, not being vectored, but told to fly direct to an initial approach fix for a VOR approach, then you might have to resort to doing this point-to-point thing. So let's say this initial approach fix that we're directed to is the 060 at 16 nautical miles. So we are on the, what point? 10 seconds. We're on the 175 at 24 miles, right there. And we want to go to the 060 at 16. So how did I come up with that being the point? Well, this is your plotting board. And the scale of the plotting board is 24 miles is the distance from here to here. And if that's 24 miles, then the distance from there to there is about 16. And I'm getting this just from the Mark 1 eyeball, saying that's you know, looks like about 16, and that's good enough. So now I want to join those 2 points in my mind's eye, and there's the line. And now I want to transpose that line, and that gives me a heading of 025. And so I've got a stiff wind from 120, so I'm going to make a heading change to 020. So here I am down here, and the point that we're going to is up there, and so this line looks straight ahead. We're going straight to the 060 at 16. So a few minutes later, we're now at 20 miles. Now the plotting board scale has changed, because this point is now 20 miles. So if that's 20 miles, then you're no longer going to this point here. You're going to a point that's about here. There we are. That's where we're going to. There's the line. Still straight up and down. So we're looking good. Now we get to the point where we're 16 miles, and this is where you can get a really good check, because you just go from here to there, and yep, the line's still straight, so we're still looking good. And here is where we're actually at 16 miles and just a few radials off, maybe 4 radials off. And if I went to 17 miles, I'd be pretty much on the radial. So you can see that plus or minus a mile, plus or minus 4 degrees is pretty darn good for just looking at it and making an assessment just using your eyeballs. Okay, holding. let's assume we're asked to hold on the 060 radial. So where's the holding radial? There. We're on the 307 or so. We're coming inbound. There's the holding radial we want to go to. So if you can visualize that, you're here, the waypoint, the fix is there, there's the radial, then it becomes really simple. You're going to just coast in here, go parallel, go for a minute, come back and home the fix. So you've got to be, once you've made that decision, you're certainly going to use all of the magic systems that we have developed using GPS and the appropriate track and so on. But just the initial look at it and instantly know what your entry is and then get the finer details. Okay, so what are those finer details? You want to think about slowing down. Within 3 miles or so, you slow down so you don't waste fuel for nothing. You get the timer up on the display, and you think about the wind, what the wind is going to do to you. And so what the wind is going to do to you is it's going to be pushing you outbound from that 060 radial. So what's happened here is we've had station passage. The bearing pointer has gone through the wingtip. So the clock, you press the enter button to start the clock, and you start your turn. Now, what are we going to turn to? If we were to just turn to heading 060, we would be blown that way. So our heading is definitely going to be less than 060. And you want to track inbound, just inside of that 060 track in order to get closer to the actual 060 radial. So I picked 052 for the heading, and here we're almost halfway through the outbound. It's almost a pure crosswind, so I'm going to go with the minute. If you had a tailwind or a headwind when you're on 060, then you're probably going to make a change to the timing, but with a pure crosswind here, we'll just leave it at 1 minute. And you have a look at the MFD, and here it tells you your track is 057. So you're getting what you're wanting. You're kind of pinching in towards the inbound radial, and that will help you in the turnaround to go back and home the fix. But I've chosen not to just home the fix, and it's for a reason. If I can intercept that inbound radial before the fix, then I can get a heading to fly for the wind correction when I'm going outbound. So that's what I've done here. I've given it about a 20-degree cut to intercept, and the bearing pointer is starting to roll out to 240, which it should be doing. And once it gets to, I guess it's just close. I've cheated a bit here. It's just close to 240, and it's about 7 degrees heading, and the track looks to be about 241. So that's 6 degrees difference between the track and the heading. So I'm going to change my heading when I'm on the outbound leg by 6 degrees. Okay, so now the question is 6 degrees more or 6 degrees less? And when it comes down to it, the wind's from your right as you're going inbound, so it's going to be on your left when you're going outbound. So a heading of 054 would probably be a good heading to go outbound with. So that was that one particular hold, and just to give you a little practice with this, just looking at the CDI and determining what your entry maneuver is going to be, you're going to get a little practice doing that now. So let's say you want to hold on the 210 radio. What's your entry? You've got 30 seconds to make up your mind. Okay, it's a direct entry. How do you determine that? Well, here's the holding radio, 210. There's the hold, right hand. And this line defines the boundaries for direct. There's another line that crosses that line, and it's 110 degrees. The angle between here and there is 110 degrees. So 210 plus 110, that makes it 320. So here's the boundary between offset and direct. And you're clearly within the direct. So in you go. What are you going to do when you're overhead? If you start your turn right there, then you're going to turn, your physical displacement when you turn is going to be half the displacement if you had been coming in on the holding radial and done a 180 degree turn. You'd be out here somewhere. But if you turn with only 90 degrees of turn, you're going to be this close. And that's going to be too close. You'll swish through the inbound radial when you turn back. So what you want to do is, whenever you're in this kind of an arc here, entering, you want to delay your turn to the outbound by a certain amount. So 15 to 20 seconds when you're at 90 degrees is what I figured out empirically. And given that we've got a 12-knot wind pushing us, we'll go with 15 seconds. And that's when you would start the turn, but you're still not out of the woods because you started the clock here, but when you roll out, you're here. And so now you've got to modify your outbound timing because you are obliged, when you're on a direct entry, you're obliged to make this 1 minute leg reasonably accurately. And it's no problem when you're in this kind of an area because you come in, you hit there, you do almost 180 degree turn, maybe a little more than a 180, but it's a lot closer to coming straight in and doing the 180. So there, yeah, you should be coming pretty close to the 1 minute. But here, you've got this kind of broken field running, you've got to figure a few things out. So if you're in a flight test scenario, what the examiner is looking for is your logic. And so if you are mumbling away and you say, okay, I'm going to delay because I want to get further out, I want to get further the normal spacing, but I'm only going to delay 15 seconds because I got a tailwind, and when I get here, and okay, I'm going to turn at 48 seconds instead of 60, then that will show the examiner that you understand the logic. And he will give you a little leeway on the actual precise 1 minute timing. Okay, so next scenario is hold inbound course 320. You got 30 seconds. Okay, the only way you can be on a radial and coming inbound to the fixed on a course of 320 is if you're on this 140 radial. So that's the radial. You're here, and the radial is there. So that determines an offset. Now the offset boundary starts at 110 degrees from 140. 140 plus 110 is 250. There, 250. So you're clearly in the offset. There's no discussion there. However, the heading you turn to would be 30 degrees less than the 140 normal outbound. But we've also got this wind that's pushing us to the right. So you'd probably go over maybe 105, something in that order. And it's also a bit of a tailwind. So you could knock off 10 seconds and turn back in at 10 seconds to come and then capture 320 inbound. The next scenario. Hold inbound course 260 left turns. What is your entry? 30 seconds. Okay, holding inbound 260 means you're on the 080 radio. You're here. There's your holding radio, but the hold is on this pad, on this side. And so that puts you into an offset, a left-hand offset. So 080 plus 30 degrees, 110. But with that wind, 105 would be more appropriate and a little less time, just as in the previous example. So those are a few of the basic IFR procedures, and when you get into your professional flying, you won't get much opportunity to practice this sort of thing unless you make yourself do it. So whenever you can, just turn off the GPS or put the track bar someplace else and give it a try, and it'll be worth your while.